Welcome. Fine. So this class is a continuation of previous class, random variables part 1. If you can search in YouTube with my name Dinesh Gutha uh, or random variables part 1. So that lecture, and this lecture is a continuation of that lecture. This is part 2. Part 1 was already discussed. Right. So now I'm continuing the lecture from wherever I stopped in the previous lecture. So in the previous lecture I was talking about properties of PDF and properties of CDF. So let us continue from here. So we have understood previously about PDF and CDF, probability density function and cumulative distribution function. So whatever we have understood in the previous lecture, same thing we are writing as properties. So the first property we are writing as for a discrete PDF, which means for a discrete random variable, if you write the properties of CDF, we are writing the properties of PDF of discrete random variable here. So the PDF of discrete random variable has values which are always between 0 and 1, because discrete PDF will have discrete PDF will consist of probabilities at different values of the random variables. So and the probability of any value of random variable is definitely less than 1 and it is definitely greater than 0. So this is the first property. Similarly, that is same thing if you talk about for a continuous PDF. For a continuous PDF, so let us discuss and let me take an example and discuss. So this is a continuous PDF. I am taking one particular example. So the range I am taking it from minus 1 by 4 to plus 1 by 4. So the height should be 2, then only the area will be 1. Then only this will be a valid PDF. Though if the height is 2, then only the area will be 1. Then only this PDF is a valid PDF. Right. So if I'm asking you what is the probability at x equal to 0, don't say it is 2. It is definitely not 2. But the function value at x equal to 2, x equal to 0, function value at x equal to 0 is 2. That is perfect. But the function value in a continuous PDF, in a discrete PDF, function value and probability both are exactly same. Whereas in a continuous PDF, function value and probability both are not exactly same. So probability at 0 means it's not same as the function value. You should understand probability at a particular point as area from 0 minus to 0 plus. For example, if I'm asking about probability at 0, then understand it like this: 0 minus to 0 plus, whatever numbers are there, only one number is there which is 0. For those numbers between 0 minus to 0 plus, what is the probability? This is exactly same as this. So for 0 minus to 0 plus, whatever numbers are there, you just need to find the area of it, right? So this area, if you want to find this area, the width is 0, width is almost 0, the height is 2 units, the probability is going to be how much? It is almost 0. Or if you think of it as, since width is almost 0 and height is 2, 2 into almost 0 is 0. If you say it as 0, you can say it as 0 exactly. If it is exactly 0, if you are thinking of it as exactly 0, then for this point the probability is 0. For x equal to 1 by 8 also probability is 0. Because the width, if you are thinking of probability as width, the area from 0 minus to 0 plus, if you are talking about probability at 1 by 8, so for example, let me take one more thing. Probability at 1 by 8 is equal to probability of 1 by 8 minus less than x less than 1 by 8 plus. What is the meaning of it? This, find the area of this PDF from 1 by 8 minus, which means just a value which is just before 1 by 8 to 1 by a value which is just after 1 by 8. So if you find that small strip area, that also turns out to be almost 0. If you take it as 0, then all the numbers are having probabilities at 0. If you add up all the numbers, the total probability also should be 0, but the total probability is not 0, right? So that's why this value, this is not exactly 0, because the area of this small width, this small width area is not exactly 0, it is almost 0. But we cannot write what is almost 0, that's why we generally write it as 0. But that does not mean that the probability at a particular point is exactly 0, but it is approximately 0. It's a very, very small value. If you are thinking of it as 2, for example, if you are thinking of the probability as 2, probability cannot be 2. That is first thing. Second thing is probability. If you add up all the probabilities, that should result in 1. So if you are taking the probability value as the function value, then the addition of all the probabilities may not result in 1. So that's why the function value is different from probability. Function value at 0 is different from probability at 0. So let me take one more example so that you'll get more clarity. Let me take a function which is from minus 2 to plus 2. So width, it is uniform PDF. It is uniform PDF. So as a function of x, I have plotted fx of x. What should be the height so that the area is 1? The height should be 1 by 4. Now tell me, what is p of x equal to 0? P of x equal to 0 is nothing but, we can write x equal to 0 as 0 minus less than x less than 0 plus. From 0 minus to 0 plus, just find the area. Always understand probability as area. So you are trying to find the area in this region. And how much is that? It is approximately 0, which we write it as 0. Okay. Don't think that probability at x equal to 0 is 1 by 4. It is not 1 by 4. For discrete PDF, whatever value is visible, let's say if I'm plotting a discrete PDF, let's say this is 1 by 3, 2 by 3, and 0, 1. Let's say I've plotted a PDF, random area which takes values 0 and 1 with probabilities 1 by 3 and 2 by 3. Now this is the PDF. Whatever value we are seeing here, that itself is the probability. But for continuous PDF, whatever value you are seeing here, whatever is the function value, that is not same as the probability value. There is a small difference. You have to observe that. Now, similarly, p of x equal to 1, that is also 0. Probability at a particular point, you can find it as area between 1 minus 2, 1 plus, which will be 0, which you can write it as 0. 1, correct? If you put x equal to infinity, here in place of upper limit, you have to put infinity. Minus infinity to plus infinity, that is definitely resulting in 1. So same property, if you want to write it in terms of CDF, this is how we write it. Fine. So let us make some more observations here. These are the properties. If anybody says CDF, cumulative distribution function, that should satisfy these two properties. And how about fx of minus infinity? Fx of minus infinity means, substitute in this definition, minus infinity here, which means upper limit should be minus, whatever is the value here, that is the value here, and this value decides the upper limit. So if it is minus infinity here, so minus infinity to minus infinity, the range width is 0, so the area also will be 0. It's like you are finding the area from minus to minus infinity only, which will be definitely 0. Next, how about p of x less than or equal to x naught? How can we write this one? For a discrete PDF, you can write it as, here the meaning of internal part, just understand